Okay, so last night I jumped on the discussion board and I saw two things that concerned me. And I really want to stay out of the discussions because I want that to be a place for you guys to discuss things. And I've seen how valuable the discussion boards can be where students sort of feel free to express their ideas without the professor jumping in, no. Speaking of the jumping in, no, one of my first concerns was that someone had, actually several people had indicated that they found things a bit frustrating in the class because I was questioning some of your answers. I like to think that that's a really good thing. Do we have any student athletes in here? Okay, yeah, 4 right there in the middle. Okay, so this is a chance for the middle people to talk. So, what's it like to be a student athlete?
You have to juggle a lot of stuff.
You have to juggle a lot of stuff. Is this easy, hard, a joy, frustrating, what? Sometimes it can be frustrating. So you do volleyball, right? So you do volleyball. How do you find practices? Like, how would you describe them? Well, maybe we don't want to enter this. So maybe someone who did volleyball or track and field in high school, how would you describe your practices then? Because I know you, it's just fun and roses, right? So what were track practices like? No, that's right. I don't want to talk about it.
Okay, in high school it was easy because I was a thrower. I didn't do running.
Easy. As a thrower, you didn't do running, so you just like come up and you're like, yay, wow, that went far.
Basically.
Yay, that went far. Well, that's interesting. Were you competitive in?
I was a top thrower.
Top thrower. Anyone else have different experiences in high school?
Football was awful.
Football was awful.
Coaches.
Why would you do it? Were your parents like, you have to do? Really?
Yeah.
All right, well. Were there other people whose parents didn't force you to do football or basketball or whatever? Why did you do it? Was it fun? Was it like torture?
Swimming. It was really nice because I smelled like chlorine for months. And practices during the winter, because it was in Wisconsin. During the winter, I would go days without seeing the sun because it would be like you have early morning practice, so you have to get in there like 6 in the morning till 8, and then afternoon, so like 3 to 5.
Is this? I'm guessing this was in college.
No, this was in high school.
Oh wow, cool.
Yeah, and then so I just lived in the sun, and I mean that was fine, except I just kind of it became my life for the most part.
How were VO2 max days? Did you guys do that? How were VO2 max days?
Those were terrible.
They were terrible. They weren't enjoyable at all.
No.
So you guys know what VO2 max is?
We also had the
So VO2 max is this thing where you basically push yourself as hard as you can go. If you're sprinting, you just run as hard as you can for a certain amount of time, and then you take a brief break, and then you do it again. Or for swimming, you just and then take a break. So I swam in college, and I was going to say most of the workouts were frustrating, but I didn't participate in swimming for the workouts. I participated for the meets and the camaraderie and all that other stuff. VO2 max, so it's, I believe, volume of oxygen that your body is capable of metabolizing at the peak of your performance. So if you go to the Sports and Exercise Science Lab here, they have a machine you can run on a treadmill, and they'll measure your VO2 maximum output, which can tell you basically how fit you are. Anyway, it's brutal exercise. And it's not really fun at all, except for those who are extremely masochistic, which there are some, and that's fine. But anyway, why do people do it? It's not for the enjoyment of the practice necessarily. It can be for the enjoyment of competing, the enjoyment of those other things. And I like to think of a good education as being similar to that. If you aren't being challenged, if you're not being frustrated with the materials, then maybe things are a bit too easy. Maybe you're not pushing yourself hard enough, even if your instructors aren't doing enough. As I mentioned in the syllabus, like, I'm here to help guide you. I can't learn for you. And in any class, that's true. And now is probably one of the best times to be a student because you have the internet. Even if I suck, you can go on the internet and look at other people's explanations of things, and we're going to differ in places. And that difference is actually interesting. The first class we talked about what an independent variable was briefly. I'm going to talk more about that in a couple of weeks. And Dr. Timmerman and I apparently have this disagreement. I mean, we are both PhDs in the area, and we can disagree on this, and this is sort of fun. We have the opportunity to think about things and reinterpret what other people have given us, what our predecessors have built, and try to find better ways of interpreting the data, try to come up with better definitions for things. So when I challenge you on your definition, it's not because I think you're stupid or your definition is bad. I often have incredible difficulties coming to definitions for simple terms. William James, in trying to define what attention was, I believe he said something like, attention, we all know what it is, but no one can define it. It's hard. Coming up with definitions that stand when you push against them is really difficult. Defining a drug is something that really escapes me. It's a substance that affects the body's metabolism. Well, if I stick a knife in your heart, that's going to affect your metabolism, but I wouldn't qualify that as a drug. Is water, is this a drug? It affects my metabolism. Without it, I'm going to die. But is it a drug? Ugh. Definitions are really tricky. Socrates was a master of this, right? So, I knew nothing, and he would come out and people would say, virtue is this, and he'd say, really? And he would question the definition, and when pushed far enough, the definition would fall apart. It was kind of interesting. So, embrace the frustration, and you'll get more from it. That said, if you feel that I am frustrating you in a way that is inappropriate, if you feel demeaned, or you feel as if I'm threatening you in some way, not physically, but intellectually, or something like that, please let me know. And you don't have to let me know by sending an email to wnap@eou.edu, where it will say that, Ken, you're Tyler, okay. So where it would say that Tyler says, Dr. Knapp, I think you're really mistreating me, blah, blah, blah. Because maybe Tyler doesn't want me to know that, because then I can just bully him more. Right? Yeah, cyberbullying. Or in the classroom. So I've actually built my own website, wnap.com. And on my website, if you go to my contact page, there's a way for you to send me email anonymously. So you can use that to provide me anonymous feedback about this course. And I mentioned this on my syllabus, but I didn't cover it the first day. You can give me feedback if you think that things are going well in this course. You can give me feedback about things you think are going poorly in this course. I would suggest that any feedback you offer would be framed constructively, so not just like, this course sucks, I hate it, but this course sucks because you go way too fast and I can't understand anything that you're saying. If you would slow down, that would help immensely, right? And then I can take that feedback and I can use it to modify what I'm doing right now. So you don't have to wait until the end of the semester to provide feedback on the evaluations. Does that make sense? And you don't have to identify yourself if you feel like I'm demeaning you. You could say, I've been talking to some students, and they've said that when you, question their answers, that they're feeling really like you are basically calling them stupid or something like that, which is not at all my intent. I want this to be an open environment where we can discuss issues and come to a better understanding of what that truth might be. Groovy? So what that truth might be brings me back to the second thing that I wanted to briefly mention, which is about skepticism. So someone said something, and I know this was in jest, but it's an important issue to mention. So they said, oh wow, I'm much more skeptical now, except for you, of course, Dr. Knapp, or something like that. And I am an authority figure. I'm the professor. I have a PhD. I may very well have my own agendas. And you should question the things that I tell you, because I might be lying to you some of the time. Or I might withhold information to you some of the time. Why would I do that? To protect my butt. That's exactly right. So when you're a brand new teacher and you don't really know the ins and outs of the things that you can do with students, you might say things. For example, like a student leaves a blank on an exam and they're failing your course, and you might indicate, this is BS, please write something, and then you find out that by saying that, you get in trouble. And you don't have tenure yet, so you can't be like, oh, okay, well, I have tenure. I can handle stuff like this. But no, I need that job. I need that tenure. I can't handle the controversy. So you stop making those types of comments, which to me is really sad, because some of the most valuable things I have to say to students, I can't say. Or at least I've come to the conclusion that it is not wise for me to say. In terms of like class materials, I'll usually tell you, what things are and how I'm thinking about stuff. But when it comes down to like maybe how you're performing in class and how this is making me perceive you, or how my other faculty members are perceiving you, and how this could affect your potential for you to get letters for graduate school or employment, I don't say it, because I don't want the dean to call me up and ask me why I told the student that they're, that I perceive them in this way. I also, once when teaching a class, made a mistake. So I'm primarily a cognitive psychologist, and in cognitive psychology, when people are talking about traces, they're often talking about a memory trace. A trace, if you think about it on a piece of paper, is basically a copy of something that's not there. In a memory trace, right? It's a copy of something that's not there. So I remember the class on Wednesday, and I have a copy of this in my brain that seems to be good enough to remember that you were not there. What? So, right, this is a trace, a memory trace. And I was teaching this class on learning, and if any of you guys have learned about operant and classical conditioning, there are different types of conditioning that you can do. You can do forwards conditioning, backwards conditioning. There's a type of conditioning called trace conditioning. And as a cognitive psychologist, I'm like, memory. And I got the idea confused, and I thought trace conditioning was when the stimulus was no longer present and you have a memory trace. Well, it turns out that was totally wrong. And I discovered it that night when I was going through my notes, and I was like, oh, I did it wrong. So what did I do the next day in class? I corrected myself. I said, hey guys, I just want to start off this class. I was wrong about this, so I presented it this way, and this is why I presented it that way. People, when they have related concepts, sometimes they'll have Freudian slips, or they'll get the two things confused. Like sometimes I'll say independent when I mean a dependent variable, just because they're so closely related in my head that I might misspeak. So I told the students this, and I told them what the real trace conditioning was. And I thought, oh great, that's beautiful. We're going to be able to go on through here, and now my students know a better version of the truth. And it turned out that was really stupid for me to do. Like from that point on, like the students were questioning my authority. Oh, is that really right? And in the evaluations, I got nailed. Oh, the teacher doesn't know what he's talking about. He said that this was that, but it was really something else. That doesn't look good. So, what do I do now? I still correct myself. 100%. In classes, there are lots of mistakes in textbooks, on the internet, with the things that your teachers tell you. And sometimes it's just easier to let that mistake go by and not ask the question on the test about it, because some student's going to come up, well, you said this and the textbook said that. So that way I'm not going to grade that. We'll just let that slip over and they can take another course later down the road. Do I do that? Maybe, maybe not. I'm not telling. But anyway, so question the things that your instructors are presenting to you. Not only will it help to ensure that you are learning the truth, or a good version of that, a good enough version, it will also help you to engage more in the material, which should increase levels of processing, which if you take in cognitive psychology, you know that deeper processing, this more critical, skeptical processing, should relate in deeper processing, which should enhance your ability to retain the information for the long term. So, question. That said, okay, one more thing. So someone mentioned, what's your name?
Allison.
Allison. Okay. So before the class started, Allison said something about nihilism. And something came up on the discussion board about, well, I can't prove this, that someone loves me, or whatever, and I'll have to think about how to prove it. One, don't try to prove it, because you can't. You can't prove it. But that said, you don't need to be nihilistic about it. You don't need to be like, well, geez, I can't prove that my wife loves me, so I'm just gonna, sit in my room and cry. Okay, so you don't need to sit at home and cry. And, I can't prove that they love me, maybe they don't. No, you've got tons and tons of evidence all around you to suggest which friends are good friends and which friends maybe aren't good friends, and what people love you and what people don't, and what dogs you should avoid and which ones you shouldn't, right? Tons and tons of evidence. So you don't need to be pessimistic about the lack of proof. And in fact, I think the lack of proof is something that makes science one of the most incredible ventures. I can't prove the theory of evolution. I can't prove the levels of processing hypothesis. I can't prove any of this stuff, which means that I could be wrong, which means I could do new tests to examine the validity of these ideas. This means that there will always be jobs for scientists. Yeah, job security. Does that make sense? So be skeptical, but don't be like, oh, I can't deal with life anymore because I can't even know if I'm true. I mean, ergo cogito sum, right? I think therefore I am. Oh, yeah. I'm not sure if I got that one right. I don't speak Latin, so. I think therefore I am, but I don't know what I am. Okay, so let's talk about the scientific method, because the scientific method is what skeptical scientists use to try to figure out what the truth is. So what parts do we have for the scientific method? Some of you guys have probably talked about this in other courses. Hopefully some of you guys have talked about this in high school. So what do you have? Are you counting fingers? This one is the first part of the scientific method? Is that what you're doing?
Hypothesis, right?
There's a hypothesis in the scientific method. There's what?
Theories.
Theories. A lot of times I write things down that aren't necessarily right. I'm not saying that you're wrong, but I like to see what people are thinking and then talk about them. Frustrating. So we have hypotheses and theories.
Before that, I think there's something like wrong or something we want to find out.
Something wrong. There's a question.
We should review the literature on the subject so you're not just chasing a rabbit hole.
Review the literature. Literature. Yeah, Tyler.
Test your hypothesis.
Need to test. Hypotheses. Maybe predictions. Because predictions could come from hypotheses or theories. Right? Anything else?
Yeah, they will
Replicate. Why replicate things? Otherwise, it could just be an outlier, a poorly designed study. What's an outlier? Because I'm sure that a lot of you guys haven't had stats.
Like once in a blue moon, it shouldn't normally happen.
Once in a blue moon, it shouldn't, it should happen, right? Once in a blue moon, something could happen. So it's possible that levels of processing is just a bunch of garbage, but in the one experiment that I did, I happened to get lucky. And participants, for some random reasons, produced data that supported that idea, right? So by replicating, I can look and see if I can get the same results from the same procedures, from the same methods. Yeah?
Just kind of a random question. Are
Yeah.
we supposed to know what the levels of processing is?
No, so levels of processing is the idea that the deeper you process information, the better your memory for that information.
Oh, yeah, you just
That's
talked
it.
about that.
So that's an example.
Yeah.
A lot of times I'll try to bring in examples from other areas that I'm not going to test you on these
Okay,
examples. I'm going to be testing you guys on this type of stuff.
Yeah.
Anything else?
Need to analyze your results.
Need to analyze data.
Come to conclusions.
Analyze data. I'm going to say interpret. T, not a D. Interpret data, which is basically the same thing as coming to conclusions, right? Because it's the interpretation of those analyzed data that allow you to come to the conclusions. Anything else? You guys are talking back there, so you can ask me.
Their methods.
Methods. I'm going to stick that with, or maybe not stick that here, but come up with a test. Right? The test that you come up with, those are your methods. Then you actually do the test. There was a hand over here, was that you, Ron?
After you interpret it, you have to present the data.
Ah, presenting the data. So you analyze it, you interpret it, you communicate with others what you found. Anything else? Yeah.
Even when you finish the entire process, you have to start all over again.
So you have to start all over.
Well, I mean, even once it's been communicated, if somebody wants to do another study on it, they're basically going back to your theory.
Okay, so there's this going back to the hypotheses and the theories.
Yeah.
So like, I think what you suggested is maybe after looking at the data, you can ask another question
Yeah.
based off of those findings.
Huh, so you look at the data. What do we call it when we look at something? Say what?
Developing new questions.
We develop new questions, but where do these questions come from?
The conclusion.
How about before we have any results? Because we're missing something. We're missing the first part. No, that comes in the analyzed data.
God.
Reject all. Oh, beautiful. You had stats with a good instructor if you said fail to reject. So what's first? You have to find something to ask a question about. Where do we find these things? It relates to a way of coming to knowledge.
Observation.
Observation. Observation. And I'm going to define observation extremely broadly. So observation can be like, ooh, there's something neat. I wonder why that is. Actually, that's an observation followed by a question, right? That I wonder what that is.
You got 2 steps done.
Yeah, isn't that amazing? So when I was living in Colorado, there was this, hopefully I didn't tell you guys this already or I'm repeating myself. So I was out in the mountains and it was snowing and it was beautiful. And the mountains were very far away and it was a fairly cloudy day, but in the distance there was a break in the clouds and you could see the snow coming down in the distance. Huh? What?
I said, like that.
It is pretty. It is pretty. But I had this bizarre experience. I was looking at the mountains and it looked like the face of the mountains were melting away. Oh, Colorado. That one's not legal. Yes. So I had this experience where it looked like the mountains were actually moving downwards. And I thought about, like, why would this be, right? I had this observation and I came to this question, why is this? And then I tried to come up with an idea. And this idea is one that was based on some of my research areas. So my primary area of research in graduate school was focused on sensation and perception, particularly visual perception. And I know that when people have a hard time perceiving depth, which we do for things that are very far away, we're good at perceiving depth for things that are up close. Yep. Yep. But we're not so great at perceiving things that are really far away. Or perceiving depth for things that are really far away. So I thought, maybe this is interesting. Maybe my brain is seeing these mountains that are so far away that to me, my brain, it's just far. Those are far. And the snow also coming down that was lit up. My brain didn't say like, oh, that was nearer. It just said far. So perhaps the reason that this mountain appeared to slide down is because my brain was saying mountain far, down stuff far, mountain far sliding down. I conjoined those two. Do any of you guys know what an illusory conjunction is? So I show people a bunch of things really quickly. There's a red circle and a green square, boom, and I show it to you so fast that you're really not completely sure what you saw, and I ask you what you saw, and some people will say, I hope I don't mess this up, red square. Did I say red triangle? And yeah, okay, good. So some people will say the color of the triangle and the shape of the square, because their brain didn't have enough time to process that information accurately, and they conjoined the wrong pieces of information together. So maybe that's what happened with my mountain. Does that make sense? So I've come up with this idea. What's the difference between an idea and a hypothesis?
Hypothesis is testable.
We can test a hypothesis. Same thing with theories. A theory can be tested. So not all ideas are necessarily testable. And one of the things that differentiates good science from bad science, maybe I shouldn't say they're not testable. They're not falsifiable. One of the things that differentiates good science from bad science is falsifiability. So, let me shift this over. Right up here. Falsifiability. What is it?
The ability to prove that something is
Good,
wrong.
Oh, so the
Ability to bring reasonable evidence that something is wrong.
Wow, reasonable evidence that something is wrong. So if we have an idea and we could potentially gather evidence that would support the idea that that idea is wrong, then that means that that idea is potentially falsifiable. Make sense? So what would be an idea that is not falsifiable?
Have you ever heard of the teapot going around the sun?
I have.
Well,
I'm not sure if it was the sun. My memory's not that good. I thought maybe it was Saturn or Uranus or something else. But yeah, the teapot out there somewhere in space.
Yeah.
So what's the idea with the teapot in space?
Well, the idea is that somebody could tell you there's a teapot. Let's say it's spinning around the sun because we can't really get close enough to see. So there's a teapot spinning around the sun, and you could make up a bunch of facts about the teapot and make up an entire story about it. But we could never get close enough to the teapot, or because the sun is too hot and it would kill us, so we'd never really find out if the teapot existed or not, and thus we could never prove that it was false.
Or gather sufficient evidence to demonstrate that it was false.
Keep on using that word.
He's exactly right. And part of another part of this is that the absence of evidence doesn't, how does it go? Absence of evidence does not or should not be used as evidence of absence. Something like that, right? Just because I don't see that there's something there doesn't mean that there's not that thing somewhere. It's like the idea that all swans are, there are no black swans. If you've never seen a black swan, that doesn't mean that there aren't any black swans. I'm pretty sure that there are black swans. You can Google it. That's another great use for cell phones in the class. Google to double check your professor immediately. Anyway, just because you haven't seen any black swans doesn't mean that there aren't any black swans, right? You just haven't been enough places, potentially, or at enough times, potentially, to demonstrate that, in fact, some swans are black, right? So, so this teapot could be potentially floating out there. In fact, on this Earth, we have a whole bunch of teapots floating around the sun, right? But this is not a teapot on Earth. This is a teapot just orbiting around the sun. And I would say that this is, right, it can't be falsified, right? You could never gather enough evidence to suggest that it is not there. You could gather evidence to suggest that it is there, right? Does that make sense? You're fighting your lip, and I like that. It means you're frustrated. So if I said there is no teapot orbiting the sun, can I falsify that?
No.
What do you mean? There's no teapot orbiting the sun. This is easy to falsify. Or maybe it's not easy to find the data, but there are potentially data that could falsify this, right?
You could say that the sun is way too hot and it would burn up the teapot.
I don't know, ceramics are amazing materials.
Yeah, there you go.
So teapots are often made out of ceramics, and you don't want to put a tin teapot out there. Yeah, it'll burn up. But ceramics,
Yeah.
the right distance, could work. No, there's no ceramic teapot, certainly in the sun. How do I falsify this? Get the Hubble telescope. I put on a big filter so it's not going to get burnt out from focusing right at the sun. And all I need to do is say, aha, look, see this little thing? We zoom in on it far enough, and oh, it's a teapot. And look, it's going around the sun. So I can falsify that, right? I can't falsify that there is a teapot.
Wait, so you mean that you can't falsify, you could say there is a teapot?
Yeah, there is a teapot. There it is.
Yeah.
But if I never find evidence for that teapot, like I can't say, oh, well, it's not there.
You
It
can
could
say,
be.
I haven't found it yet.
I haven't found it yet. That's exactly right. Are any of you guys fans of Disney? Yes, okay, Tori. Have you seen any of the Tinkerbell movies?
Yeah.
Of course. So my daughter, she likes Tink and her friends, and there's a movie where like Tinkerbell meets her like twin sister or something, and she's on the cold side, and oh, we don't want our wings to break, blah, blah, blah. So I have a theory about why the frost appeared on my car this morning. You guys know what that theory is? It's the Tinkerbell theory. That's right. So alongside our universe is a parallel universe, or maybe we could think of this as being the same universe, but a parallel dimension that normally we're not aware of, right? And in this dimension are the fairies. And it's just like the Disney movies. It's incredible how they intuited this, because, I mean, it's real. There are fairies out there. And when the temperature gets low enough, it doesn't create frost. It's not condensation or anything. It's magic. When the temperature gets low enough, the fairies are able to interact with our parallel dimension in such a way that, like, it's like the movie. So they're just seeing the flowers and the stuff, and they're going, sprinkle, 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 dinkle, dinkle, and the frost is appearing, and it's beautiful and wonderful. But we can't see those fairies. They live in a different dimension. And they can only interact with our dimension in this very unique way by adding frost to things. But otherwise, they can't touch us, we can't see them, we can't measure them in any way. Can I falsify that? No. I can't falsify that. There are these things that are out there that you can never see. Which is interesting, because there are ideas about parallel universes. Has anyone been keeping up with the CERN super collider? What they're planning on doing?
Way bigger.
To do what?
Find different atoms that are before even the Higgs boson.
So not atoms.
Or yeah.
Higgs boson is much smaller than that. But like subatomic particles and things like that. And one of the things that they're interested in trying to find or trying to do is make a black hole. You guys heard about this? They want to produce a mini black hole. And some people are freaking out about this. Oh my goodness, you're going to make a black hole, the whole world's going to collapse, blah, 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 blah. Maybe!
Oh,
Maybe!
yeah.
Probably not. Probably not. There are a lot of physicists and mathematicians working on these things, and I'm pretty sure that they have concluded that the evidence is that they can create this black hole that will only exist very briefly and should disappear and not destroy our world as we know it. So no one has to be worried about like the first of the new Star Treks that came out. You know, our world isn't going to implode, hopefully. So, one of the things that math, well beyond my ability, has predicted is that there are these parallel dimensions. How do you prove don't. How do you demonstrate evidence that would suggest there are these parallel dimensions? Well, one of the predictions for these parallel dimensions is that if there are these parallel dimensions, then what should happen when that black hole is created is that there should be this, they call it a gravitational rainbow, and we should actually leak some gravity into that parallel dimension, if their mathematical models are correct. So if their mathematical models are correct, we should see this gravity leak. Not see visually, but using the sophisticated technology stuff that I don't understand that they're using. The same type of logic was used to infer the existence of the Higgs boson. It's not like they saw the particle and they're like, oh my goodness, there it is, oh, it's beautiful. No, they used decay particles. So the Higgs boson is thought to decay in a certain way, and they are capable of measuring these decay particles. And there are lots of different particles that would produce those types of decay particles, but the Higgs boson is supposed to produce them in a particular ratio. So what they did is they ran like billions and billions and billions of very small experiments. And they looked at all of the data and looked at all the decay particles and tried to infer whether or not the number of these different decay particles that are coming out are consistent with the Higgs boson, which they were. So they're making predictions about this parallel universe in a way that can be tested. If I had a prediction about these fairies that I could test, like at exactly 32 degrees Fahrenheit, if you use a silver wand with I don't know, I'm trying to think of some fancy Harry Pottery type of thing on the inside, with a white horse hair, yeah, on the inside, and you wiggle it like this, like 3 snaps in the Z formation, then you'll feel the little tug of the fairies. Now that's a hypothesis that I can test, that I could potentially falsify. Does that make sense? Then we run into this prediction, or this problem where if we don't find evidence, it doesn't mean that they're not out there. Maybe the fairies just don't feel like tugging right now. Maybe I didn't do my Z formation in the right way, right? So good science, good theories, good hypotheses are falsifiable. This is a boundary for science. We can't really test predictions about things that we can't falsify, which is actually really cool. So in my intro class that I was teaching online recently, we were talking about something and evolution popped into the conversation, and a couple of the students on the discussion boards like indicated like, oh, you know, when I see evolution, I just shut down because it conflicts with my beliefs. As if evolution and their beliefs are necessarily completely contradictory with one another. A lot of people I know, because I grew up surrounded by a number of people that told me, like, you can't believe in this and believe in that, they're mutually exclusive. And they told me things like scientists, they're all atheists and they don't believe in God. And that's just not true. There are lots of scientists out there that do believe in God. The problem that science has with God is not whether it exists or not, it's a problem of falsifiability. So a lot of people's conceptions of God is that God can do anything that God wants. And that God created everything. Well, if God created everything, then everything that you could possibly see is consistent with that idea. There is nothing that you could ever see that is not. Does that make sense? It's not falsifiable. What else is characteristic of a good theory or hypothesis? Falsifiability and a P word. I forgot to shave this morning. Does anyone know my favorite brand? It's not Schick or Gillette. Schtick? Or is that just what I do in front of class? Bic? Schick? Whatever? No. It starts with O. Do I have stuff on my face? I was going to say occasionally I get.
No, you said Bic, and that's like a brand.
No, it's not Bic.
It
It starts with an O. Occam's razor.
I never would have gotten that.
Tyler, do you know what that is?
right?
No! Does anyone know what Occam's razor is? It's not actually a razor at all.
Shave off a certain probability that's not true. Something that you can use
You make it yourself.
No. All right, you have a cell phone. Are you Googling this right now? Sweet. So Occam's razor is not actually OCC
I see it.
AHMS, I believe.
Occam's razor.
Is it AHM?
It's a principle.
It's a principle.
It's not a real razor at all.
What is the principle?
Among competing hypotheses that predict equally well, the one with the fewest assumptions should be selected.
Among competing hypotheses that explain the data equally well, the one with the fewest assumptions should be accepted. This is also known as like the parsimony principle. Parsimony. You guys know what parsimony is? Yes, good. You know what parsimony is, so you know Occam's razor. What's the parsimony?
Isn't it believing the easier answer over, or taking in the...
Taking in. I don't want to say believing, but taking in. So, why did the flowers frost? Why did people's tulips die this morning? I'm so sorry, Derek. Was it because the tulips were really cold? They were colder than the air around them. And when moist air cools, what happens? It condenses, right? So the moist air condensed on the flower buds. And it was so cold that this condensation froze. And these tulips are dead. So that's one idea, right? So that involves cold air or moist air condensing as it gets cooler. It involves a cool object and a warmer environment. This is why in the summer you put your iced tea or ice whatever up on something and you notice that it gets wet, right? So that's one idea. The other idea involves these fairies that only work at certain ways, and I made a ton of assumptions about how that works. So it could be the one, it could be the other, which is the one that science is going to go on. They're going to go with.
Probably the former.
The former, because it's simpler. It's easier to explain. And this is another reason why science is focused on naturalism. So the idea that all events have natural causes as opposed to supernatural causes. Because assuming that there is a supernatural cause means that you have at least one more assumption to make. And it's not a falsifiable assumption. So not only is it less parsimonious, it's not falsifiable. Which is why science and theology are different areas of investigation. Monday, if you guys want to get started, we're going to talk about statistics. Yay! We're going to look at graphs, like bar graphs and scatter plots. We're going to look at the mean. We're going to look at standard deviation, variance, covariance, and correlations. Actually, that will be most of next week. Next week is our correlation week. So you can